This is the continuation of the video that got cut short last time. I was in the middle of number 4. We were trying to graph this cosine function. And so let me just review what we learned. We learned that this had an amplitude of 3, a period of 4 pi, a phase shift of negative pi, and a max value of 1 and a min value of negative 5, which meant that our baseline is the vertical shift, which is negative 2. So I had gone ahead and kind of marked off a red dashed line at negative 2 to indicate that that's kind of the center of all of where my x-axis used to be. So when we go and look at this, we need to make sure that we have our starting point of our shape and our ending point at the beginning at negative pi and at 3 pi. So if I try to graph this shape right here, because we have a reflection of cosine, which means it goes down and then up and then back down. So at negative pi, I need to be on the lowest point that my graph can get, which is at negative 5. So here's negative pi, and here's negative 5. The next thing is that at the end, at 3 pi, I would return back to that same value. So to figure out where we're going to be for our top value of this cosine function, we need to be halfway between negative pi and 3 pi. So negative pi plus 3 pi divided by 2. So that is 2 pi divided by 2, which is just pi. So that means at pi, we would be at our highest value, which is positive 1. So if you notice, I've already kind of marked off these, but if you're counting by pi's, which is what it looks like we're counting by here, because there's 1, 2, 3, 4, 5, which is exactly the number of points that we need, we end up on our baseline at 0 and at 2 pi. So I'm going to go ahead and graph that best I can. And then the directions did say to graph from negative 2 pi to 4 pi, so I'm going to kind of just continue counting pi over and pi over and noticing that that returns us back to that baseline of negative 2. Okay, let's talk about number 5. It says that given the information below, we need to find the exact values for sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha plus beta. So we're looking at doing our sum formulas here. So let's write down what those formulas are so that we can use them in just a second. So remember that sine, the way we remembered this in class was that sine is social and agreeable. Social means that it intermixes, so sine, alpha, cosine, beta. And agreeable means it keeps its sign. Plus, this time though, we would want sine of beta, cosine of alpha. And then we have cosine of alpha plus beta. Cosine is antisocial and disagreeable, so the cosines stay together. And it changes signs because it's disagreeable. Sine alpha, sine beta. Tangent of alpha plus beta is, and you could prove this by, putting sine over cosine, but we don't want to go through all that. So it's tan of alpha, keep your sign, so plus tan of beta over 1 minus, and this will be a plus if the top is a minus. So this is always opposite sign here. And then it's tan alpha, tan beta. Okay, so we need to figure out sine, cosine, and tangent of both alpha and beta so that we can plug them into the formulas. So down here, I'm going to draw a little graph for each one. Alpha is in quad 1. So we have alpha here, and that is opposite over hype. And we'll want to use Pythagorean theorem to figure out the other side of that triangle. So 37 squared minus 12 squared, because that's our hypotenuse, equals 1,225 raised to the 0.5 power. Let's see if that is a nice one. It is. It's 35. So that means that sine of alpha, we already knew, was 12 over 37. Cosine of alpha is 35 over 37. And tan of alpha is 12 over 35. Okay, let's draw what we know about beta. So beta is in quad 4. with negative, or tangent they gave us this time, which is opposite over adjacent, and negative for the y value, so negative 20 over 21. We'll need to use Pythagorean theorem again, so 20 squared plus 21 squared is 841, and that, let's see if that's a perfect square. Yep, it's 29. So sine of beta is opposite over hype, so negative 20 over 29. Cosine of beta is adjacent over hype, and we already knew tangent of beta was opposite over adjacent. Okay, so we should be able to go back up here and plug these in. So for this first one, sine of alpha is 12 over 37. Sine of beta is negative 20 over 29 plus, or sorry, I was talking before I was reading. Cosine of beta is 21 over 29. Sine of beta is negative 20 over 29. And cosine of alpha is 35 over 37. So if we multiply the bottoms together, so 37 times 29, that's 1,073. The top, we have 12 times 21, and it's going to be minus because it's negative times positive, 20 times 35, getting negative 448. Okay, let's move on to the cosine one. So we have cosine of alpha, which is 35 over 37, times cosine of beta, which is 21 over 29, minus sine of alpha, which is 12 over 37, and sine of beta, which is negative 20 over 29. We're going to get our 1,073 as our denominator again. And for our numerator, that is 35 times 21. And then that's going to be plus, because it's negative, negative, 12 times 20. So that's 975. Now, if you don't want to try to plug into the tangent, if you've done these two correctly, you can just do sine over cosine, and you'll see that that gives you the ratio for your tangent. But let's go ahead and work it out. So tan of alpha is 12 over 35, plus tan of beta is negative 20 over 21, over 1 minus 12 over 35 times negative 20 over 21. So let's figure out that bottom part. That's going to be 12 times 20 is 240 over our 1,073. So this will be 1 minus 240, or actually it'll be plus because it's minus a negative, over 1,073. On the top, we want to go ahead and get a common denominator here because we're going to do the same thing in the bottom in just a second. This would be times by 21. So 12 times 21 is 252, minus 20 times 35. So it's negative 448, which we expected, over 1,073. On the bottom, you'll do 1,073 plus the 240, which something doesn't look right there. Hang on just a second. Did we miss a sign? Oh, I know what I did. Let me back up just 1 second. This is not 1,073. I just didn't even multiply it out. 21 times 35 is actually 735. That's why that wasn't coming out right. So both my denominators are 735. So we get a 735 over 735 plus the 240, and that's going to give us our 975. So I get negative 448 over 735 over 975 over 735. So when you multiply by the reciprocal, you get the negative 448 over 975. Again, if you've done cosine and sine correctly, you don't actually have to find tangent using the formula. You can just do sine over cosine and you pretty much get the same answer. So let's look at the next one, which is our double angle formulas. So we're going to write those down first, and then we'll work out the problem. So remember, a double angle just means like you're doing sine of theta plus theta. So if you think about it, that would be social and agreeable. So sine theta cosine theta plus sine theta cosine theta, since the angle is the same. So that's why sine of 2 theta is 2 sine theta cosine thetas. Cosine of 2 theta, I'm going to use the version you get from the addition formula, which is cosine squared theta minus sine squared theta. And tangent of 2 theta is 2 tan theta over 1 minus tan squared theta. So we're just going to use what we have here. This is telling us that our cosine is 60 over 61, and this is in quad 4. That helps us draw our picture. So this is cosine is adjacent over height. So we need to use Pythagorean theorem to find the other side of that triangle, which is 121. So square root of that is 11, and that'd be negative here because we're in quad 4. So this would be a sine of theta, because that's what this is negative 11 over 61. Cosine of theta we knew was 60 over 61, and tangent of theta is negative 11 over 60. Okay, let's go back in and plug in what we know. So this is 2 times negative 11 over 61 times 60 over 61. That's going to be 61 squared is my denominator, so 3,721. On top we do, that's going to be negative 22 times 60, so negative 1320. I don't have a good calculator that lets me check to see if that is reduced or not, so I'm just going to pull up the answer key, and that's how we left it, so it must be reduced. Obviously, you would check that on your calculator on the test. For the next one, we have cosine squared, so that's going to be 60 over 61 squared minus sine squared. Realize that if you square that, that negative in the inside is going to go away. So 60 squared is 3,600 over 3,721 minus 121, because this is going to square to a positive, but there's still a negative in the middle, over 3,721. So minus the 121 on top, 3,479 over 3,721. So that's going to be our cosine. And then again, we could just do sine over cosine to get our tangent, or we can show it in the formula. So 2 times negative 11 over 60 over 1 minus negative 11 over 60 squared is negative 22 over 60 over 1 minus 121 over 3,600. We could get a common denominator on the bottom. That's going to be 3,600 minus 121, which is 3,479. So we have negative 22 over 60 all over 3,479 over 3,600. Multiply by the reciprocal of the bottom. And you're going to see that the 60 goes into this a certain number of times, which is 60. Times that by the negative 22, and that's the negative 1320. So negative 1320 over 3,479, which is what we would have gotten if we'd put in sine over cosine and just reduced that. All right, now we're looking at number 7. This is about the half-angle formulas. So the half-angle formulas, I'm going to need a little more room here. We have sine of theta over 2 and cosine of theta over 2, and then tangent of theta over 2. So each of these is solved from a double angle formula from cosine, the version where you have either 2 cosine squared minus 1 or 1 minus 2 sine squared theta, and you solve those kind of for the sine theta or the cosine theta. Now, the tangent one is just a ratio of the two. So it's always going to be a plus or minus, but the sine one is 1 minus cosine theta over 2. The cosine of the half angle is plus or minus square root of 1 plus cosine theta over 2. And then tangent is plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. So the problem with the half angles and why this is a little bit trickier than the original adding or subtracting or the double angles is because when we take a square root, there's a plus or minus that gets thrown on. We have to determine whether or not we're using a positive or a negative for each trig ratio based on the location of the half angle. So this tells us where to draw theta, but to figure out if you're choosing plus or minus, you have to know about your half angle. That's why we always take the ratio that is provided to us and we divide it by 2 everywhere to figure out the location so we know if we're doing plus or minus. So I'm going to go ahead and do that. So negative 270 divided by 2 is negative 135, and negative 180 divided by 2 is negative 90. So just imagine for a second where that would be if you're going counterclockwise. So negative 90 is here, negative 135 is here. That means you're going to be in quad 3 for your half angle. So this is where theta over 2 is located. Now, why do we care about that? Because that means sine down here is negative, cosine down here is also negative, and tangent here is positive. This little side journey right here only tells us what signs to pick. So we're going to pick negative, negative, positive. Okay, that's the only reason you needed to know that. Now, the rest of this is going to be based off of where theta is. So we do need to draw theta in its correct location. So I'm going to do that here. We'll do it in red, because this is the information we're going to actually plug in for our cosine. And we only need the cosine. We don't need any other ratio. But they gave us tangent instead of giving us cosine. So negative 180 is here. Negative 270 is here. So that means for our theta, we're in quad 2. Let's draw that triangle. Tangent is negative 45 over 28. So the negative is on the x value on this quadrant. And then we would do 45 squared plus 28 squared. And we need to take a square root of that, which is 53. So my hypotenuse is 53. And that tells me what my cosine is. So cosine of theta is negative 28 over 53. Okay, so here's what we have. Sine of theta over 2 is going to be negative square root of 1 minus negative 28 over 53 all over 2. Cosine of theta over 2 is going to be negative square root of 1 plus negative 28 over 53 over 2. And tangent of theta over 2 is going to be positive square root of 1 minus negative 28 over 53 over 1 plus negative, and this is all underneath the square root, 28 over 53. I recommend multiplying everything on top and bottom by 53s to clear out those fractions. This would be 53, so this is negative square root of 53 plus 28 over 2 times 53, which is going to be 106, I think, but I'm going to double check myself. Yeah, 106. And we'll want to add the top, so 53 plus 28 is 81. So this is negative square root of 81 over square root of 106. Square root of 81 is 9. 106 divided by 2 is 53. Neither one of those is perfect squares. So we're just going to rationalize this. So it's negative 9 square root of 106 over 106. So there's my sign. On this one, it's going to be negative square root of 53 minus 28 over 106. So that's going to be 53 minus 28 is 25. So negative square root of 25 over 106 square rooted is negative 5 over square root of 106, which is negative 5 square root of 106 over 106. And then lastly, you could work this one out, or you could just realize that it's going to be sine over cosine again. So this is positive, and it's going to be a square root of 81 on top and a square root of 25 on the bottom. So it's 9/5. And that's it for that one. Okay, and this is going to be the end of this video. Originally, I wanted to do 1 through 8 on the first video before I got my video got chopped off. So let's look at use trigonometric inverse functions to find the solutions of the equations that are in the intervals 0 to 360 degrees. Approximate the solutions to 2 decimal places. Okay, so I chose to do B. So imagine thinking of this as just like an algebraic equation. So 20x squared minus 7x minus 6 equals 0, where x is standing in for cosine theta here. So then we would multiply the AC method and get negative 120. We want factors of negative 120 that are going to make negative 7. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and, let's see, is that 120 divided by 5 is 24. 6 and 20. 7 I don't believe goes, but we're going to double check. 8 and 15, and that looks like the pair we need, because if you have a positive 8 and a negative 15, that makes negative 7. So 20x squared plus 8x minus 15x minus 6 equals 0. Pull out a 4x in the first pair. That leaves you with 5x plus 2. Pull out a negative 3 out of the second pair. That also leaves you with 5x plus 2. So we're getting 5x plus 2 and 4x minus 3 equals 0. So this is actually x equals negative 2/5 and x equals 3/4. But remember that this was not really an x, it was a cosine. So cosine of theta equals negative 2/5 and cosine of theta equals 3/4. When you're solving for an angle, you need, and it's not one of our nice angles like on a 30, 60, 90 or 45, 45, 90, you use your inverse button. The only problem with using the inverse button is remember that inverses are only defined when a function is 1 to 1, which means you're missing one of the answers in the 0 to 360 range. So we will have to think about where each of these ratios could be for cosine. So when you have a cosine of negative ratio, you always get an answer in either quad 2 or quad 3. Now the thing about the inverse is it gives you the quad 2 answer because the inverse is defined from 0 to 180. So if we do negative 2/5 and we take the inverse cosine of that, notice that's 113.58 degrees measured from 0. So 5/8. Now that will be one of my answers because that is measured from 0, so that's correct answer for this part. But the problem is we also should have another angle that has the same reference angle down here. Now the problem is you don't know the reference angle yet. So minus that from 180 will tell you how much is left right there. It's 66.42. which means this is also 66.42. So this angle down in quad 3, we have to add 180 plus that. So since mine's already negative, I'm just going to subtract it. So it's 246.42. There's the second angle for that part. So this one was given to us by the inverse. This is the other place where a cosine could have a negative 2/5 ratio. Then we would want to look at this one, and if you do this, you're going to know that cosine has a positive ratio in both quads 1 and 4, but the inverse only gives you quad 1 for cosine. So if we do 3 divided by 4 and inverse, 3 divided by 4, hit enter, and then inverse cosine, 41.41. And notice this time that actually is the right angle because it is measured from 0. So 41.41. But there's also another 41.41 reference angle, which is always from the angle down to the x-axis down in quad 4. For this one, though, you need to say 360 minus that to get its measurement from 0. So 318.59. And like I said, that's going to be the end of this video. There'll be another part that goes through the remaining 8 problem types.